All right, so let's start with the do now before we get into our new learning target on factoring by grouping. So it says factor the following quadratics. You do not need to find the roots, and then factor out the GCF of each polynomial. Again, don't find the roots. So pause the video and give those a try. Okay, we're back. So when we're factoring where a value for a quadratic is 1, we look for numbers that multiply to c and add to b. Got a little for you. So multiply to 14, add to 9, so those numbers would be 7 and 2. Switch to blue. For number 2, multiply to negative 15, add to negative 2, those numbers would be negative 5 and positive 3. And then number 3, multiply to 12, add to negative 8, those would be negative 6 and negative 2. So those would be our factors. For the bottom, it says factor out the GCF. So we start with just our numbers, so 5 and 20. So the greatest common factor for 5 and 20 would be 5, because I can divide each by 5. Then we move to our variables. They both have x's, so I can factor out an x. I just take the lowest exponent, so we have 5 and 3, so 3. What remains then? So 5 divided by 5 is 1. X to the 5th divided by x to the 3rd is x to the 1st. 20 divided by 5 is 4. X to the 3rd divided by x to the 3rd is nothing. So I just have x squared plus 4. For number 5, largest number I can divide 10, 14, and 6 by is 2. They all have x's. The lowest exponent is 3, so 2x to the 3rd is my GCF. To write the remaining polynomial, 10 divided by 2 is 5. X to the 8th divided by x to the 3rd would be x to the 5th. 14 divided by 2 is 7. X to the 5th divided by x to the 3rd is x squared. And 6 divided by 2 is 3. To the 3rd divided by to the 3rd cancels. And there we have it. All right. So our new learning target today is another method of factoring to find roots. It is called factoring by grouping. Factoring by grouping. So let's go through a few problems here. I'll outline our steps, how this works, and then I'll give you a chance to try it on your own a bit. So here we go. So we have x cubed plus 2x squared minus 9x minus 18 equals 0. Our goal is to find the roots. So factoring by grouping. As we look here, no GCF here. So we can't factor out a GCF first. That should always be our first step if we can. When we factor by grouping, you factor out the GCF based on a group or based on terms. So what we do here is we're going to separate this into two sets or two groups and factor out the GCF and find the remaining binomial for each group. So for x to the 3rd and 2x squared, we start by factoring out the GCF for just those two numbers. So x squared. So in terms of coefficients, numbers in front, just 1. They both have x terms, so I can factor out an x. The lowest exponent is a 2. So x squared would be my GCF. What remains would be x to the 3rd divided by x squared would just be x. 2x squared divided by x squared. 2 divided by 1 is 2. X squared divided by x squared cancels. So I have x plus 2. Then I do the same here. So I have negative 9 and negative 18. So I'm going to factor out a negative 9. Only one of our terms has an x, so x cannot be a part of that GCF. From there, right, what remains? Negative 9 divided by negative 9 is 1. X divided by nothing, well, we just have that x. Negative 18 divided by negative 9 is x plus 2. So, to be able to factor by grouping, after factoring out the GCFs, your remaining sets in parentheses, which in this case are binomials, must be the exact same. So if they are the exact same, then what we can do, and this is really the process, this is the grouping that takes place, is we can take these multipliers. So x squared minus x squared and negative 9. That constitutes our first factor times our original factor. And the reason we can do this is because, like, if I were to distribute this, I would just have x squared times x plus 2, or times x times 2. I would have negative 9 times x plus 2. So I'm just rewriting this, grouping these together into two factors. If we were to work backwards, we'd just have negative 9 times x plus 2 and x squared times x plus 2, which is what we came up with. But now we have two factors where we can seek or try to factor those further if possible into and come up with our roots. So as I'm looking here at this x squared minus 9 is an x squared term, so that's usually something that we factor. So we can try and factor that out into what multiplies to c and adds to b. So the numbers that multiply to negative 9 and add to 0 would be positive and negative 3. And now I just have three factors that we can set equal to 0 to find our roots. So I take x plus 3, set that equal to 0. I take x minus 3, set that equal to 0, and x plus 2, set that equal to 0, and solve for x. So in this case, I'll subtract 3 from both sides to get x equals negative 3. Here I'll add 3 to both sides to get x equals positive 3, and then subtract 2 from both sides to get x equals negative 2. So my roots would be negative 3, negative 2, and 3. So let's run through the steps that we took to do this. So step 1 was to factor GCFs by pairs. So we take our first pair of terms, factor the GCF. Take our second, factor that for the GCF. And then we didn't really do this necessarily, but we should do this mentally. Check to see if remaining polynomials are the same. That's what we did next. We checked to see that x plus 2 and x plus 2, those are the same. From there, you can write your two factors. After that, if we can, we factor further. And the last we find our roots. So those are the steps we'll continue to take now for our second problem. So here we have 2x to the third plus 5x squared plus 8x plus 20. So we start with our first two terms, factor out the GCF. So I have 2 and 5, so can't factor those into anything because they're both prime. But we have x cubed and x squared, so they both have x's. The lowest exponent's a 2, so x squared would be my GCF. From there, divide each term by x squared. So 2 divided by 1 is 2. X cubed divided by x squared is x. 5 divided by 1 is 5. X squared divided by x squared cancels. So I have 2x plus 5. So when I'm factoring now these second two, I want to make sure that my remaining polynomial is the same. So let's see our numbers first. So 8 and 20, those are both divisible by 4. So 8 divided by 4 is 2, x divided by nothing is x, 20 divided by 4 is 5. So that looks good, they're both the same. So now what we can do is we can write out our factors of x squared plus 4 and 2x plus 5. So we wrote our two factors, next says factor further. So if we can, we want to do that. So as I look here at x squared plus 4, that's the only thing we could potentially factor further, and we'd have to look for numbers that multiply to 4 and add to 0. Numbers that multiply to 4 and add to 0, that doesn't really work for us. We can't do that. So there is no way for us to factor that further. So then we find our roots by setting those factors equal to 0. We'll solve the one on the right first, so subtract 5 from both sides to get 2x equals negative 5. Divide by 2 to get x equals negative 5 over 2. Okay? For the other, subtract 4 to get x squared equals negative 4. Take the square root, get x equals plus or minus the square root of negative 4. So plus or minus comes in whenever you take the square root. There's always a positive and negative solution. Square root of a negative, that's not something we like. Remember, put this over here. When we have the square root of negative 1, that's equivalent to I. So what we should do, separate that into negative 1 times 4. The square root of negative 1 times the square root of negative 4, which we know the square root of 4 is 2. The square root of negative 1 is I, so we get plus or minus 2I. So imaginary number roots. Woo. Okay. Alrighty. What do we got left? Okay. Here's a third. If you feel ready to try this on your own, pause the video and give it a try. If not, I'll walk through it with us, so you can pause now. Okay, so here, when we're factoring by grouping, so separate our first two pairs. And I should note, it's nice if you have it ordered from highest to lowest exponent. So if it's not, you will want to set it up that way. So here, x squared would be my GCF, because there's nothing I can factor from 4 and negative 3. And x squared is my lowest exponent. So that leaves me with 4x minus 3 as my GCF. Here we have negative 36x plus 27, so as I look to 36 and 27, I know 9 I can divide both by. Negative 36 divided by 9 is negative 4x. 27 divided by 9 is 3. As I look here, don't have the same remaining polynomial, so that means we need to switch something up. So let's keep that first one the same. I'm noticing same numbers, just different signs. So let's just change the sign of this 9 to negative. So negative 36 divided by negative 9, that gives me 4x. 27 divided by negative 9 gives me negative 3. So that fixes things for us. So if when you're factoring it out you don't get the right signs, just change the sign of your GCF. That should do the trick. So from here now, I'm going to put my work up here. We can write our two factors, so x squared minus 9, 4x minus 3. X squared minus 9, that's something we can factor further. Remember, we did that up here. That factors into x plus 3, x minus 3. Now we can set all those equal to 0 to solve for our roots. To which we'll get negative 3, positive 3, so add 3 to the last, so divide by 4, we get n 3/4. So these would be our roots. And there's our solution. Okay. All right. We have 2 more problems here. So why don't you pause the video, give those a try, and then we'll check back in and go through them. Okay, we're back. Let's run through these real quick. So GCF here would be 3x squared. Remaining would be x plus 2. Then we have negative 12 and x plus 2. So that checks out. They're the same. So 3x squared minus 12 times x plus 2 equals 0. Interesting setting here. So notice our a value is not 1. What we can do here is we can actually factor a GCF out of this one if we'd like. So factor out 3 from each. And now this looks like something we could potentially factor. X squared minus 4, so multiply to negative 4, add to 0. It's a difference of squares, so that'd be x minus 2, x plus 2. So now when we're setting these equal to 0, you don't have to set this 3 equal to 0 because it doesn't have a variable. There's nothing for us to solve for. So we just set each of these, I'm going going to do them all separately. Each of these factors equal to 0. And, oh, we get x plus 2 coming up twice. So we don't have to do that twice. It's just showing the same root. So that's not necessary, so we really only have 2 roots here. Okay. On to the next. So we can factor a 2x squared out of the first to give me 4x minus 3. Negative, what is this one? 16 maybe? Or no, 18? Yeah, minus 18 will give me 4x minus 3. Yep. So I've got 2x squared minus 18 times 4x minus 3 equals 0. Again, noticing I can factor a GCF out of that one. X squared minus 9 will factor into x minus 3x plus 3. And 4x minus 3, to which when you go ahead and solve, your root should be 3, negative 3, and 3/4. And there we have it.